Hi there. Thanks for coming tonight. I'm Marty Ritchie from the Corporate Communications Group here at SRI. Before I begin, I wanted to share some news. We're going to be, after hosting the cafe for 7 years, we will be winding it down later this year, by the end of the year. We're hoping that they'll find a new home. We'll have a new home for the cafe in the future. But our next cafe is scheduled for May 12th, although we're still looking for a speaker for that event. Following that, July 14th, Dr. Alenka Hubicki of San Jose State University will talk about planet formation, so we hope you can come to that. And also, as usual, please watch your email and visit the cafe website for information about upcoming events. And as a reminder, you can watch past events on our YouTube channel. And the URL for that is listed on the bookmarks that you can pick up on the way out if you'd like. But tonight, we're so pleased to welcome Dr. Marshall Burke, who will speak on the social and economic impact of climate change. A hot topic, if you'll pardon the pun, if ever there was one. So, more than lukewarm, yes. Dr. Burke is an assistant professor in the Environmental Earth System Science group at Stanford University. His research areas include adaptation to climate change, agricultural development, climate effects on food security, and the influence of climate on human conflict. Dr. Burke will take your questions at the end. We'll have a couple of microphones set up in the back of the room, and thanks for using them so we can capture your thoughts and questions on video. So without further ado, please welcome Dr. Marshall Burke to the podium.
All right, is this guy working? You guys hear me all right? Great. Well, thanks, Marty, for the introduction, and thanks to you guys for having me here. I'm glad I squeaked in the door. I didn't realize the cafe was sort of winding down here, so I'm glad I got to participate before it got wound down. As Marty mentioned, this talk is on the social and economic impacts of climate change. And just chatting with some folks in the audience beforehand here, I realized that this is the broader topic of climate change is one of immense interest to people in the area. Which is great. It's of immense interest to me too. And the reason I think this particular topic is exciting right now, so the understanding more about the impacts of climate change, is because just in the last few years, we've actually been able to learn so much more about how human systems and society at large responds to changes in climate. So a lot of what I'm going to show you today has a whiff of gloom and doom about it. A lot of the news is not good. But sort of the broader hope is that the sort of things that we're learning can help inform policy and help us make better decisions. So I'm going to punt on the difficult political problem of actually getting those decisions made, and I'm going to show you what I hope is some evidence that will help inform those decisions that will hopefully get made in the future. So, but before getting into the impact question, let's start by just sort of remembering where the debate is right now. So this is the debate we're having, and hopefully you guys can hear this. Representing the climate change denialists, if you will. These videos are actually quite easy to find on YouTube. I encourage you to not go down this wormhole of searching for these videos on YouTube, but here's a representative one. This is Representative Paul Brune from the 10th District of Georgia a couple years ago.
The idea of human-induced global climate change is one of the greatest hoaxes perpetrated out of the scientific community. It is a hoax. There's no scientific consensus.
Okay, well, I'm glad that got some groans from the audience. It doesn't always, which makes me uncomfortable. Representing the other side is John Oliver, who has a show on HBO. He used to be on Jon Stewart, if you know him.
You don't need people's opinions on a fact. You might as well have a poll asking which number is bigger, 15 or 5? Or do owls exist? Or are there hats?
Okay, so clearly funny, right? But this is literally the debate we're still having, right? Arguing about whether there is or isn't a scientific consensus. So at least on the science side, we're pretty sure that science has spoken clearly on this, right? There's incredibly strong scientific consensus that the planet is warming, one, and that humans are mostly to blame, two. And I'm comforted by the fact that sort of the best polling evidence that we have suggests that the majority of Americans now believe these two things and will tell them to you unprompted. So people are becoming more educated on climate change and actually more likely to believe that it's both happening and that humans are to blame. So again, scientific facts, some change in public opinion. But again, This is the debate, you turn on the TV and every second or third night this is what we hear. Okay, so that's the debate we're having. What's the debate we should be having? And so this starts to get into the topic I'm interested in. So here I'm showing you the estimated effect of warming, of temperature increases on GDP, on gross domestic product, which is sort of our main measure of the amount of stuff we produce in the world, right? So these are estimates from the most recent IPCC report. The IPCC is the Intergovernmental Panel on Climate Change. They're the sort of global entity charged with understanding climate change and sort of disseminating its magnitude and its effect to the global populace, right? So this is sort of our best estimate from the science. And so on the horizontal axis there, the x-axis, you can see different possible increases in temperature going into the future. And on the y-axis are the estimates of the impact of those increases on global gross domestic product, so the global size of the economy, if you will. And what do these suggest? So if you sort of squint, you can imagine this is sort of downward sloping, right? The impacts appear to get more negative as things get warmer. Let's see if my poker works here. Yeah. So there's that's going to make a funny noise every time I do that. I'll try not to. So a downward sloping relationship, right? But let's look at these magnitudes, right? So they say up to 3 or 4 or 5 degrees Celsius warming, which is about what the business as usual sort of warming scenario would be for 2100, right? So that's going to be a pretty warm world. That would say we're going to lose, 6 to 7 to 8% of global GDP relative to a world that didn't have climate change, right? So is that a big number or not? So arguably. So one way to think about it, so let's imagine a world then that's growing at 1% a year, right? Through sort of the magic of compound interest or compound growth, in 100 years, we're going to be, if we grow at 1% a year from now, we're going to be 170% richer, right? That's a lot richer. So if these estimates that I just showed you are correct, then in a world with climate change, that means we're only going to be, 168% richer, right? So does that sound like a big deal? Now that sounds like a little bit less of a big deal, right? Okay. So all of my research then, or most of my research, is in trying to understand whether these damage estimates are actually correct, right? Are these actually the numbers that we should be using to sort of determine climate policy? And I'm going to spend the rest of the talk telling you that the answer to that question is no. These are not the numbers we should be using. And I'm going to show you a range of evidence suggesting that the economic impacts are likely to be much more negative than the current estimates in the IPCC chapter that I just showed you would suggest. So, again, here's the gloom and doom. Hopefully I'll bring it back to try to bring it back to a rosier picture at the end, but if I don't, tell me to. Okay. So how can we study climate damages, right? So damages I'm using sort of generically to mean sort of any bad thing that might happen to a social or economic outcome that we care about, right? It doesn't have to be the case that climate causes damages, right? It could, and I'll show you some evidence that there actually will be some beneficiaries of climate. Some people will be better off as the climate changes. So how do we study this? So imagine the following experiment, right? We have some outcome we care about. So let's say it's per capita GDP. So per capita incomes in a given country, right? So one way to look at this would be to take two countries, right? Take Norway and Nigeria. Okay, what do we know about these countries? So Norway, as we know, is very rich, right? It also happens to be, at least since the Vikings, quite peaceful. And it's also cold, right? I've been to Norway once. It was the summer. I couldn't bring a big enough jacket. California makes you sort of soft, I guess. Okay, so Norway, rich, peaceful, pretty cold. Nigeria, on the other hand, pretty poor still. Pretty conflict-prone, especially recently, and also quite hot, right? It's sort of right on the equator, quite hot. So the naive thing to do might be to look at these two things. Okay, so Norway Norway is cold and rich, and Nigeria is hot and poor, and you might conclude, okay, temperature is the cause of poverty, right? Okay, so people are laughing. That's good. That's good. So why do we laugh at that? So we know that that Nigeria is hot, but it's also a lot of other things, right? It has different institutions. It has a different governance structure. It has different neighbors. The countries around it are different, right? And all these differences are going to be correlated with the temperature, right? Norway has other differences too. It has different institutions. It's surrounded by peaceful neighbors, right? So the climate variable that we care about is going to be associated with all this other stuff that might also affect the outcome that we care about, right? So this sort of thought experiment is not going to be a good one to identify the effects of climate on these outcomes that we care about. Okay, so what's a better design? Here's a better research design, and this is more or less the one we're going to sort of employ in the research I tell you about. So instead of comparing Norway to Nigeria, let's just focus on Norway, or focus on Nigeria in particular. So take Nigeria. Let's compare Nigeria in a normal year, in a normal temperature year for Nigeria. So the average temperature there would be maybe 26 or 27 degrees Celsius, so 70 to 80 degrees Fahrenheit or something. Hot there, right? So compare Nigeria in a normal year to Nigeria in a really hot year, right? And then take the outcome that you care about, so it's per capita GDP or it's some conflict measure, and measure how that responds as Nigeria changes temperature, right? So what that allows you to do, it holds constant all the other stuff that varies across Norway and Nigeria, right? You're not changing institutions, you're not changing neighbors or anything. All you're doing is changing the temperature. And so what that allows you to do, again, is to really sort of identify the effect of temperature on the outcomes that you care about. So this is sort of the research design we're going to employ. So I'm going to start out by showing you a bunch of evidence from smaller scale studies from different parts of the world that speak to different parts of this problem. And then I'm going to show you new research that sort of aggregates these small scale results up that we're working on right now to give you sort of a more global picture of how large the economic impact might be. Okay, so first piece of what I'm going to call micro level evidence. Again, these are from sort of smaller scale studies around the world. So people have been studying for a long time the relationship between climate and agriculture. This was sort of one of the areas where we were initially worried, and I say we as sort of the broader academic and policy community, we were initially worried about the impacts of climate change. So we know if you're growing crops, what happens to the weather, right? What happens to rainfall or temperature really matters and directly matters for how much you can produce in a given year. Okay, so what do these studies tell us that look at these relationships? Okay. First thing they tell us is that plants really don't like it hot, right? I think when we normally think of bad agricultural conditions, so take California in the last couple of years, right? It's been really dry, right? We've had these sort of historic droughts. But part of the problem has not just been the rainfall, but also been the fact that it's incredibly hot the last couple of years, right? We're multiple degrees above sort of average temperatures for California, right? And when you have a lot of data, you can really pick apart this effect, this particular effect of temperature. And what all the data we have suggests is that temperature itself, actually more than rainfall, is what really matters for agricultural productivity. So what I'm showing you here is a plot of how U.S. maize yields, in the U.S. we call it corn when you're talking to an international audience. This is SRI International, I get to use maize. So U.S. maize yields, how these respond to changes in temperature. So again, the plot on the y-axis here is the percentage change, and on the x-axis is a measure of sort of exposure to daily temperatures, right? And so as you go further along, sort of out to the right, you get hotter and hotter temperatures. Okay, and so what these data tell you, I'm not going to use my poker because, oh, now it's not making the noise. Nice. Okay, sorry there too. I'll switch back and forth. But what it tells you, is up to about 84 or 85 degrees Fahrenheit. Corn yields do pretty well, right? And they actually peak at about 84 or 85. But as you start to get days above that, as you start to get days into 86, 87, 88, even hotter, productivity falls off a cliff, right? You start losing a pretty large percentage of your yield for even very, very small amounts of exposure above these thresholds, above 85 degrees. So what this actually tells you is for every day, so take an average day at 84 or 85 and replace it with a day at 85 or 86, right? So you just move one day up 1 degree Fahrenheit, you lose about 1% yield just from moving that one day up 1 degree, right? So you can imagine a hot week or a hot month and what that might do to yields across the season. So, okay. So plants don't like it hot. And this is not just a U.S. phenomenon, so I won't go through this in detail, but we see the same thing when we look at African maize yields or when we look at it in India, or sort of no matter where we look in the world, we see sort of the same relationship. So this is another plot, and on the right here is this relationship, sort of the effect on yield of again, these really hot days. And you get a relationship that is about the same. You lose about 1% for every day that you spend above these really hot temperatures. Okay, so plants don't like it hot. So the broader rule of thumb here, I guess, is that you get out of these studies, and again, this seems to hold up sort of no matter where we look, is you lose about 1% of your entire yield for that year for every day you spend above, in this case, 30 degrees Celsius, or about 85 Fahrenheit. Okay, plants don't like it hot. So how about people, right? So agriculture is an important part of the economy, but you know, in the U.S. it's only a couple percent, right? So maybe agriculture's hurt, but maybe sort of other sectors, not such a big deal. So what's the evidence on that? Okay, so here's a recent study. This used this really nice survey we have in the U.S. on time use. So what the government gets people to do somehow is fill out these diaries every day of sort of what they're doing, and they fill it out on a really, you know, they fill it out sort of hourly. So you know, I was surfing the internet. I was surfing the internet. I was, or at work or whatever, right? Yeah. So what this shows you then is the relationship between how much time people reported working and, again, temperature. So we know where the people were when they were recording the diaries, and we can relate that to the temperature, you know, that was the temperature that day, right? And what this shows, again, is actually something quite similar to what we saw for plants, right? Up until about, again, it's actually remarkably similar. Up until about 85 degrees Fahrenheit, temperature doesn't really have an effect on how much we work, right? But above that, this line starts to drop off again, right? Dropping off here, right? And it turns out on these really hot days, we work on average an hour less, right? That's like a huge part of the day. Okay, so we work less when it's hot. Not only do we work less, it turns out we're less productive even when we are at work, right? And on some level, I think this is intuitive, right? We all know that if it's really hot out, you know, you're trying to do something, you're just sort of not as productive. You're not thinking as clearly. It's just harder to focus. And that actually shows up in the manufacturing data in the U.S. So here are two studies, and this is the relationship, again, between really hot temperatures and, in this case, U.S. car manufacturing. So it turns out the number of cars rolling off the assembly line in Detroit is actually substantially lower on weeks when it's really hot. So it actually, if you have a heat wave, so an entire week where temperatures are hot, in this case on average above about 30 C or 32 C, production can fall by about 10%, right? So this to me is really surprising. This was a new study. This is not my study that came out a few years ago. Right? We think of these places as air conditioned. We think of them in sort of cool parts of the climate, right? But what this shows is that even in U.S. manufacturing, capital intensive, very advanced, right? Small changes in temperature can still have these really large effects on output, okay? We see the same thing in India, and if anything, the effects in India are even bigger. So this is Indian textile manufacturing. The effects are maybe a couple times bigger. Maybe not surprising, most of these places are not air conditioned. So the effects of temperature might be even worse in these places. Okay, so people don't like it hot. We work less. We're less productive when we are working. So yeah, actually one question I do have. So we haven't done these studies really in Silicon Valley, right? So sort of for the tech industry. We have them for manufacturing, like I showed you here. So if anyone here works for a tech company who wants to do one of these studies with us, come talk to me. I'd be excited to do so. I think there are opportunities to do it. And this is an answer we care about, right? We want to understand sort of the local effects of climate, and right now we don't have the data to do so. Okay, so people don't like it hot.